Okay, hello everyone. We are going to go through the lesson on 3.4 linear programming. You will need the document that I have attached in our Google Classroom post for today. We're going to need some graph paper in being able to solve these problems today. Just for a little information on what linear programming is, it's something that we're typically trying to find a maximum or minimum value for of some quantity. All right, so it's typically some situation. This first one will not be a word problem situation, but our next two examples will be setting up word problems. All right, so with this first example, we are going to find the values of x and y that will maximize p for the objective function p equals 3x plus 2y. All right, we'll have a point to what the objective function means when we get to some of the word problems. I just want to start going over all the steps that involve these linear programming problems before we get into one of the word problems. All right, so we are given these constraints. So these are all the inequalities that we'll need to graph. So we're going to graph the constraints on our coordinate plane here. We'll have to shade all those overlappings, and then we're going to find the intersection points where that entire shaded region would be located. All right, so let's go ahead, we'll graph this first line right here. I've got a y-intercept of -3, and then I have a slope of 3/2, so I will rise up 3 and go right 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. All right, since it has the equal to, this will be a solid line. All right, saying y is greater than or equal to, so I would shade this line above that line. So if you want to lightly shade that, you can. If you want to make a little arrow, keeping that in mind. I'll just switch my color, but if you have a pencil, a lot easier to lightly shade. I can't lightly shade, so I'll just kind of keep it that color, and we'll just kind of pay attention as we go. So I'll take this next line. Y is less than or equal to -x plus 7. My y-intercept is 7, so 1, 2, 3, 4, 5, 6, 7. My slope is a -1, so I will go down 1 and right 1, so this line slants down. Down 1 and right 1, down 1 and right 1. Okay, this is also a solid line. Oops, I should have did better job. Down 1 and right 1, down 1, right 1, down 1, right 1. We will have to be finding some points of intersection, as I talked about over here. So that's why it's so important for us to have our grid paper here to solve these problems, so that I make sure I get many points and getting them lined up correctly. All right, so if I go to shade that one, y is less than or equal to that line that I just drew. So that means I would shade underneath. So either lightly shade with a pencil or just kind of put a little arrow. Keep in mind that'd be underneath. Right now, you can see the red and the green would be where all the overlapping is occurring, but I still have 2 more lines to graph. All right, so I need to graph x is greater than or equal to 0. That means all of my x values will be positive. When I have just x, that is a vertical line. So it's actually just going to be my y-axis, and everything that is greater goes off to the right. All right, so right now, this region within here is where all the overlapping is occurring. We had to be above this line, below this line, to the right of this line. So it's kind of all happening within there. Mine's kind of a mess with all those colors, but if you have pencil, that's easy to lightly shade. The last line I need to graph would be the line y is greater than or equal to 0. So all of my y values must be positive. That will represent the x-axis and then everything above. So here's what we got for what's called the feasible region. So that's the region that's going to contain all of the points that would satisfy all 4 of those inequalities. And where each line crosses or intersects with another line within that region is going to be where we find those intersection points. So I'm going to make this region really dark. All right, the other colors that I have all over the place don't really matter. They were just there to help me determine where this feasible region would be. All right, so I have 1, 2, 3, 4 points that would make up my intersection points. So I've got the point right here is 0, 0. The point right here would be 2, 0. The point up here would be 0, 7. And then this intersection point right here would be the point 4, 3. All right, so we use those points. So here's that objective function from the very beginning. All right, that's where I'm going to plug my points in, the x and the y value for each point. And I want to find the value of x and y to maximize and minimize the function for p. Okay, so if I'm testing out 0, 0, it's not very interesting. I'm plugging in 0 for x and 0 for y, since that's the point that I have, and I'm plugging that into that objective function. So then p would equal 0. Okay, if I'm checking my next point, 2, 0, I'm taking 3 times my x value of 2 plus 2 times my x value of y, so I would get 6. For the next point, I've got p equals 3 times my x value of 0 plus 2 times my x value of 7, so I would get 14. For my next point, I've got p equals 3 times my x value of 4 plus 2 times my x value of 3, and then I would get 12 plus 6, so 18. All right, so this problem asked us the x and y value to maximize and minimize p. All right, so if I'm trying to find the maximum value is 18. That is the largest value. All right, and what are the x and y values that would give us 18? Well, x had to be 4 and y had to be 3. All right, it also asked us about minimizing p. So if I was looking for the minimum, that would have been 0. And what values made it 0? Well, when x was 0 and when y was 0. When you are doing your problems, it's only going to ask you either for the minimum or it will ask you for the maximum. It won't ask you for both, but I wanted to make sure we talked about both. When you get your problems in your Math Excel assignment, it's going to give you these constraints. It's going to give you your objective function, and then there's no grid, there's no graph paper, there's nothing for you to do but plug in what the maximum is and what x and y values you need to get there. So that is why you will need some graph paper when you're working on your problems in Math Excel today. Okay, you can't come up with all this information without graphing. All right, and we've had problems in the past where they have the graph for us and then we can use that. You will not have it in this lesson on that assignment. Okay. All right, we're going to go ahead and move on to 2 word problems next to wrap up our lesson. In our word problems, we are going to have to set up the objective function. We are going to have to set up the constraints, and then we'll graph them. We'll find those intersection points. We'll find if we're looking for a maximum or a minimum. Okay? So here's your next problem. All right, we'll go ahead and we'll take a look at that. I gave you some hints on places where we can start these problems, so use those hints in your homework as well. So we have a tray of corn muffins that takes 4 cups of milk, 3 cups of wheat flour, a tray of bran muffins that takes 2 cups of milk and 3 cups of wheat flour, and our baker has 16 cups of milk and 15 cups of wheat flour. He makes $3 profit per tray of corn muffins and $2 profit per tray of bran muffins. How many trays of each type of muffin should the baker make to maximize his profit? All right, little overwhelming, a lot of information. So let's start with defining some variables. Let's figure out what we're going to use for X and Y. All right, my suggestion is to use X and Y because we're going to treat this for our graph right here as our X and Y axis. So that'll help us when we're graphing if we use X and Y instead of using C for corn muffins and B for bran muffins. It's up to you what you want to do, but I would suggest X and Y. Okay, so we need to take a look at what the question's asking us to find. So kind of ignore everything for a second and just jump to the question. It says, how many trays of each type of muffin should the baker make to maximize his profit? So that's always going to clue us in to the things that we don't know, and those are represented by your variables. We know all about cups of milk and wheat flour, all right? So that's not going to be our variables. All right, so I don't know the amount of trays of corn muffins. So the number of trays for corn muffins. And then I don't know the number of trays for bran muffins. That's what we want to know. All right, we also want to know how many of those we will need to maximize a profit. All right, so now we're creating the objective function because our objective is to maximize a profit based on the number of trays of the muffins that we are making. So we're trying to find profit P. So in a sense, we kind of have three variables, X, Y, and P. P is not going to be in our graph. We'll come back to that when we are done graphing. All right, so if we're trying to figure out the profit, take a look back through the problem. There was a few things they told us about profit. He makes $3 for every tray of corn muffins. So $3 for every X, since X represented the trays of corn muffins. Plus, he can also make $2 for every tray of bran muffins, which is represented by Y in our variables. Okay, so we set up our variables. We have this objective function. We are going to come back to that later. Now we need to set up the constraints. These are inequalities that we'll be graphing. All right, so these have some sort of restrictions. It's going to use the other information that we have not used in our problem yet. All right, so let's take a look back through. I've got the 4 cups of milk and 3 cups of wheat flour, and that all has to do with corn muffins. All right, those are not going to be in the same inequality because I cannot add milk to flour. I can only add milk to milk. So if I want to use the 4 cups of milk for every tray X of corn muffins, I'm going to have to add the milk on to that. Let's see, where's the, okay, over here. So the 2 cups of milk for the bran muffins, every tray would be represented by Y. And then we cannot go over, so I'll use less than or equal to the 16 cups of milk that the baker has. All right, so that will be one of our constraints that we will need to graph. The other constraint that we will set up will be representing the other information we have not used, which would be all of the wheat flour. All right, so that all goes into the same inequality. So I've got, oops, I annoyed the wrong thing over here. 3 cups of wheat flour for every tray of corn muffin, plus we've got 3 cups of wheat flour for every tray of bran muffin. We cannot go over the 15 cups we have in total of wheat flour. All right, so stop a second, make sure that we have covered all of the information. So we have used everything about the milk, about the wheat flour, and the profit was thrown in our objective function. So we have used all of our necessary information. So we have basically covered all of our constraints except for 2 that we always need to remember to include. So both X needs to be greater than or equal to 0 and Y needs to be greater than or equal to 0 because X and Y are represented by a quantity. They're represented by an actual thing, trays of corn muffins and trays of bran muffins. So we can never have them be negative, because that would not make sense. All right, so when we go to graph those constraints, there's a reason why my grid does not have X and Y axes, because I'm going to fill them in right here. Right, so this is my 0, 0 point. All right, so everything within this would be the first quadrant in our coordinate plane. All right, so I'm basically taking care of graphing those right now when I set that up. Okay, so for these word problems, you're not going to want to put your X and Y axis in the middle of the graph because you're going to waste space that way because you'd only use the upper right corner. Okay, so then when we go ahead and go to graph these inequalities, I'm going to need to get them in slope-intercept form. So I want to get y by itself, so then I can set up that y-intercept and get the slope so I can find as many points as possible because I'm going to need to look for those intersection points. Okay? All right, so for the one above here, I'll have to subtract 4x from both sides. So 16 minus 4x divided by 2. All right, so the inequality I'll be graphing is y is less than or equal to 8 minus 2x. Okay. For my second inequality, I'll get get y alone, so subtract 3x. So 3y is less than or equal to 15 minus 3x. Divide everything by 3. So y is less than or equal to 5 minus x. All right, so these are the two inequalities I'm going to be graphing on my grid. All right, so starting with this one, 8 is my y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8. And then I will go down to right 1 for every point. I'll make that line. And it is less than or equal to, so right now this triangle that I have would represent all of the possibilities. So I'll just keep that in mind so I don't make this quite as messy. And then I'll go ahead and graph this line. So my y-intercept is 5, 1, 2, 3, 4, 5. And then my slope is a -1, so I'll go down 1, right 1, down 1, right 1, down 1, right 1. I might want to keep track of that intersection. Down 1, right 1, and down 1, right 1. Okay, that is also less than or equal to, so I would shade underneath that line. So this section, kind of outline it for you, and then shade it in. That is your feasible region. So any point that falls within that region would satisfy all of our constraints that we have. All right, so we wouldn't run out of ingredients, we wouldn't run out of flour, we wouldn't run out of milk, and we wouldn't have anything that would be negative and not make sense. Okay, so now I got to take those intersection points where at least two lines would intersect. And now this point right here is not an intersection point. All right, some students will use that one, but it does not fall within the shaded region, so that point would not count. Same with the point up here. That point, yes, intersects with two of our lines, but it is not part of the shaded region. So I only use the points that would enclose that shaded region. All right, so let's write down those points. I've got the point 0, 0 right here. I've got the point 0, 5. I've got the point right here that should be 4, 0. And then this intersection point here is the point 3, 2. All right, and from here, we will go ahead and now take a look at our objective function. Now this has a purpose again of why we had to set that up. And I'm going to plug in my x and y values for each of these points to determine which one's going to give me the maximum profit. Obviously, this one is not going to give me a very good profit since I am not making any trays of corn or bran muffins. So you would make $0 if you do not make anything to sell. Okay, over here, I would have 0 plus 5 times 2. So that would be $10 profit. All right, my next point, 4, 0, I would be taking 4 times 3, so that would give me $12 plus 0. My last point here, 3, 2, I would be taking 3 times 3 plus 2 times 2, which would give me 9 plus 4, so I make $13. So that is going to be my maximum. All right, so in your Math Excel problems, once again, they're not going to give you this grid. They'll just give you that word problem. You'll need to kind of set this up and go through that. And then it's going to ask you, well, what is the maximum profit? You know, it'll leave a blank for you. And you'll say, well, $13. And it's going to ask, well, how many trays of corn muffins and how many trays of bran muffins would you need to make that $13 profit? All right, so we said X represented the corn muffins, so that would mean 3 trays. We said Y represented the bran muffins, so that would be 2 trays. And that would be our final answer. So these problems do take time. There's a lot of setup. Then we have to graph. Then we come up with those points. Then we plug those points in. So it takes some time definitely to get through one of these word problems. You will not have that many in your homework. All right, but make sure you are using some graph paper so that you can sketch those inequalities because we're going to need those exact intersection points. All right. Go ahead and turn over your notes sheet. We're going to do one more word problem setup. This last one's very similar to the one that we just did. I would suggest pausing this video, try to set it all up yourself. See if you have the correct variables, objective function, and constraints. Then see what I've said, and then pause it, graph your constraints, see if you do that correctly. Press play to check yourself would be a good method at this point, okay? So in this problem, sometimes I just jump straight down to it looks overwhelming when you read through this, so I'm just going to take a look right away. How many of each type should he make to maximize his profits? So already I know, hinting at what my variables will need to be. How many of each type? So I'll take a look back. Justin makes 2 types of wood clocks. All right, so we need how many types of the wood clocks? All right, so more specifically, it takes him 2 hours to assemble a pine clock, which requires 1 ounce of varnish. It takes 2 hours to assemble an oak clock, which takes 4 ounces of varnish. He's got so much varnish and so many hours, and he makes a profit on those, okay? So I do not know the number of pine clocks or the number of oak clocks. All right, he's also want to maximize his profit. So once again, I'll go ahead and use P for profit. I need to take a look. Where did it mention how much money he can make on these clocks? Well, he makes $3 for every pine clock X plus $4 for every oak clock Y. Okay. Next, we want to set up those constraints. So now I'm going to look at the things that are restricted for us. The profit is not restricted. We want to make as much profit as possible. So that's why we come back to that one later and plug things in. The constraints are things that we only have so much of. We only have so much time, right, that he can work. We only have so much varnish before we run out. Those are our constraints, okay? Restrictions on things that we have. All right, so if I take a look back at the beginning, it takes him 2 hours to assemble a pine clock. So 2x, so for every pine clock, it takes 2 hours. I'm gonna have to add hours to hours, so I use that information. Then I need to look at where, not the 20 hours. Oh, another 2 hours to assemble the oak clock. So the same time for each clock. all right? But we can't go over the 20 hours that Justin is able to work, okay? All right, so we have another constraint because we've got varnish to work with. So in the pine clock, it takes 1 ounce of varnish, so 1x, plus I'm going to need 4 ounces of varnish on the oak. So the oak is going to use up more varnish. So we got to be careful about how many oak clocks we make based on that we cannot go over the 16 ounces that we have. Okay. If I take a look back, I have used all of the information. I've used everything about the varnish, everything about the hours. I've included the profit in my objective function. All right, I need to also make sure that I remember both x and y must be greater than or equal to 0, so that when I go and set up my graph, I fill in those lines, and now those lines and now when I have points that intersect with these lines that I just drew in for your x and y axes, now we can use those as possible critical points if it falls within that shaded region. All right, I'll go ahead and get y alone, so then we can graph these. So I'll take 2x to the other side, so 2y is less than or equal to 20 minus 2x. Divide everything by 2. So y is less than or equal to 10 minus x. That's the equation that I will need to graph. My next one, I will subtract x to both sides. So 4y is less than or equal to 16 minus x. Divide everything by 4. So 4 minus 1/4 x. And that is the other inequality I'm going to graph. All right, so I've got a y-intercept of 10. So we're starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my slope's -1, so down 1, right 1, all the way down to the x-axis. And I want to fill in all those points because I want to figure out the intersection for my region. All right, y is less than or equal to, so I would shade underneath that line. So I'll just keep that in mind so I don't make it too messy here for you to see. The next equation or inequality, the y-intercept is 4, so 1, 2, 3, 4. -1/4 is my slope, so I'll go down 1, right 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. I've got an intersection here. Sometimes it's hard to see with all my colors, so I'm just going to make that another spot. And then I got down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. All right, that's also shaded underneath since it's a less than or equal to inequality. So the place that this is all going to fall in the region will be right in here. So when I'm looking for those critical points, I've got 1, 2, 3, 4 in this case. So I'll write down those points, we'll plug them into our objective function, and we'll get to the solution of this problem. So 0, 0, once again, is a critical point. Not going to be very interesting because that'll give me a profit again of 0 if I don't make any products. All right, next point would be 0, 1, 2, 3, 4. All right, if I look at that objective function, 3 times 0 give me 0, plus 4 times 4, I would make $16. All right, this point down over here would be 10, 0. All right, for my profit, I'm taking 10 in place of the x, so 3 times 10 would give me $30. So far, best option right now. I've got one more point over here. That would be the point 8, 2. All right, so for my profit, I'm taking 3 times 8 plus 2 times 4. So I've got 24 plus 8, so I get $32. So that's going to make the most money. That's going to be my maximum. So once again, in your Math Excel program, it's going to ask you, well, what is the maximum profit in dollars, right? And you'd say, well, that'd be 32. And I would say, well, how many pine clocks did that take? And how many clocks did that take? Okay, and you'd say, well, 8 was my X, which represented the pine clocks. 2 was my Y, which represented the oak clocks. And then I would be done with my problem. Okay, that's a wrap on our lesson today. Good luck with your homework. I'll see you tomorrow. I don't know how to stop it. There it is.